In this video, we're going to look at finding function values and graphing radical functions. So a radical function is just a function that has a radical symbol in it. So a radical symbol that contains a variable in it, I should clarify. So here you have a square root example and a cube root example, but of course, any kind of radical would be fine, fourth roots, fifth roots, etc. So the first example we're going to do here is just to practice working with the function notation and kind of review that. Now, remember when we have this function notation, the value that is inside the parentheses here is your x value, or whatever your input is if you're not using x's for some reason. The f tells us which function we're using, so we're using the f function here. And then what we're going to do is we're going to replace the x with 8. So I'm going to go ahead and take that function. I'm going to replace the x with 8 instead. And then I'm going to go ahead and simplify. 8 minus 4 is 4, and the square root of 4 is 2. So f of 8 is equal to 2. Next, we'll do 6. So here we're asking us to replace the x value with 6 instead. So I'm going to go up to my function notation here. Again, I'm looking at the f function, and I'm going to plug in 6. Now 6 minus 4 is 2. So I have the square root of 2 here in this case. So f of 6 is equal to root 2. Now, if you wanted to have an approximation, you could use your calculator to simplify root 2 further. I can't do anything with root 2, though. There's no way to break it down as a radical. So at this point, you could use your calculator if you want an approximation instead. Now for g, we'll do the same thing. So I am switching functions to the g function here, but it's the same process. I'm going to let my x value be -1 this time. So I'm using the cube root, and I have -1 plus 2. That becomes +1, and the cube root of 1 is actually 1. So g of -1 is equal to 1. And in my last example here for g of 1, again, I go to my g function. I replace the x with 1 this time. 1 plus 2 is just 3. I can't do anything with the cube root of 3. There's no way for me to break that down. So if you wanted to have an approximation, you could use a calculator here. So g of 1 is equal to the cube root of 3. Now, before I keep going, again, you'd want to learn how to do this on your own calculator. If you have the TI-83 calculator or 84, or I have the app Graph and Calc 83, they're very similar. There is a way to do it. It is a little bit tricky, but you can do a cube root on this calculator. And you're going to hit the math value. And you can see, for me, it's number 4. You have a little cube root function there. So it's under there. And then I could go ahead and type in, 3 and hit enter and get an approximation that way. So for me, it's under the math key. And again, it's number 4 for me. And there's my cube root key. If you have I have an iPhone. So if I turn my iPhone, just the regular calculator to the side here, this one also has a cubed root function key. It's right here. It does have a little 3 in there. I know it's hard to see on the video. It says cube root of x. So I would do is type the number I want first and then the cubed root. So it does it the other direction. All right, but nothing new here, just using that function notation. All right, in my next example, I want to actually do one for graphing. And I do want to talk about the domain first. So remember we talked about that we cannot have negatives inside even roots, right? So a square root, a fourth root, a sixth root, etc. Odd roots are fine, but even roots, you can't have a negative underneath. You get a value that's not real. It's an imaginary number for a square root. So for domain, we have to keep that in mind. So whenever you see even roots, square roots, fourth roots, etc., we need that the inside of the root is at least 0. So it needs to be 0 or positive. Now, we may exclude 0 if the root is in the denominator, right? So we don't forget that we can never divide by 0 either. But for most cases, as long as the inside of the root is 0 or positive, again, unless you're dividing by 0 there, it should be fine. So in this case, the inside of my root is x minus 2. I would solve this by adding 2 to both sides. And I see that my domain is that x values have to be 2 or bigger. So my domain is going from 2 to infinity here. And this is going to help me to graph it as well. So I'm going to make a table here to graph. And remember that f of x is another way just to say y. So your output is going to be your y values when you graph. Now, when I pick x values to plug in, so I'm just going to pick x values to plug in here and find the answers. 2 is going to be the smallest one I could plug in. If I try to plug in 1 or 0 or anything else, I'm going to get a negative under that root, which is not going to help me. So I'm going to start with my smallest one, which is 2. And then I'm going to pick a few other values to plug in here as well. Now, if you think a little bit ahead, you may be able to figure out good ones to pick. So I'm going to do 6 because that will give me a nice root that I can work with. But if not, let me see, I'm going to pick 10 as well. You can just use your calculator. So here I would plug in 2. So for x equals 2, f of 2 would be the square root of 2 minus 2, which is the square root of 0 or 0. So there's my first point, right? 2, 0. Don't forget when you have function notation, this is your x and your output there is your y. So you do have a point when you're plugging in these values. When I do 6, and again, I just picked values. I tried to think a little bit of ahead here. And I said, okay, when I plug in 6, then I get root 4, which is 2. So that's a nice, easy one that I can simplify there. And then the last one I kind of purposely picked a little bit messier. So 10 minus 2 is 8. And we do have a square root of 8. I could simplify that, but because I'm graphing, I'm just going to go ahead and use my calculator here. And if I do the square root of 8, I get about 2.82. So I can use that to help me graph. And again, if you don't like having values like that, then you, again, think a little bit ahead so that you can find roots that you could simplify. My next root that works out is root 9. So how can I get a 9 in here? Well, I'd have to pick 11 because that would give me 11 minus 2, which is root 9. So you can sort of think a little bit ahead here to help you pick values, but if not, you could use your calculator. And I'm just going to draw a graph right here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, we'll do 10, 11. And then we'll do 1, 2, 3. So if I plot my points, I have 2, 0. I have 6, 2. And then I have 11, 3. So your graph ends up looking like this. It is an increasing function, so it actually is going to keep increasing, although it increases more slowly as you go along. But you have this sort of nice curve here, which is common to square roots. Okay, let's look at one more graphing example. Here we have a cubed root. Now, for odd powers, right? So here it's an odd index or an odd root, I should say. There is no restriction on domain. Domain is going to be all real numbers. So you only have to worry again when you have an even index or an even root. So my domain here is all real numbers. I can pick anything I want to plug in. Again, I'm going to go ahead and make a little table to keep myself organized. You do want to be careful here. Notice that -1 is outside the root. It's not inside the root. So you just want to make sure you're reading the problem correctly. And I'm going to pick values that make my life easy. So notice how it's a cubed root. So I'm going to think about my cubes in this case. So, 1, -1, 8, -8, and so on. So I'm going to choose to plug in -8. -1, 0, 1, and 8. And again, I'm thinking ahead a little bit here because I'm saying, okay, that's a cube root. I would like to not have to use my calculator, although I can. So I'm just going to plug in these values. So let's do -8 first. I get the cube root of -8 minus 1. The cube root of -8 is -2, and -2 minus 1 is -3. When I plug in -1, I get the cube root of -1 minus 1. Cube root of -1 is -1. Minus 1 is -2. When I plug in 0, I get the cubed root of 0 minus 1, which is 0. So I get -1. When I plug in +1, cube root of 1 minus 1, cube root of 1 is 1, minus 1 would be 0. And when I plug in 8, cube root of 8 is 2, and 2 minus 1 is 1. Now you could pick more values as well. Usually for complicated problems, like anything that's not linear, you probably want at least, a few points here until you can see the pattern. If I have all real numbers for my domain, I do like to pick negatives and positives as well. So let's see what we have, and then we can decide if we need to find more. So I have 1, 2, 3, 4, 5, 6, 7. There's 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Just do my best to stay somewhat consistent here. And let's go ahead and plot these. So I have -8, -3, -1, -2. I have 0, -1. I have 1, 0, and then I have 8, 1. Now, again, you may want to put in some more values here. This is a graph that I'm pretty familiar with. So you get something like this. This side does keep increasing, although very slowly. It doesn't quite plateau like I have here. It does keep going up. And this side does keep going down. It just very slowly. If you think about your next cube, after 8, it's going to be 27. So at x equals, 27 is when you're going to move up the next tick mark. So it does increase and it does decrease forever, going kind of both directions here, but just very slowly. But as you're graphing new functions, you do want to make sure that you have enough points so that you can understand what the graph looks like. And of course, you can always check these with a graphing technology. So if you have a graphing calculator, or I always like the Desmos app, you can check your work on there as well and make sure that it is doing what you think it's supposed to be doing.